start, the second phase of the project is due now, so if you do have them, come and leave them here with me. We're not marking the first two phases of the project. We're just giving you feedback on what it is that we want you to do for the actual project. Okay? Still, I strongly encourage you to do hand them in and also take advantage of our TAs giving you feedback on those. The second question submission deadline is June 9th. I've added the link both to here and the website for you guys to hand in that second clicker question. Tutorials this week are going to be in a lab. Okay, so they're going to be in X-Wing 350. They're not going to be in this classroom or 101 instead. Okay, so make sure that you don't come here and you go straight to X-Wing 350. And the exam date for CPSC 304 has been finalized. It's going to be Monday, June 23rd. And we still have a lecture on Friday, a few days before that, so it's going to be tough. Make sure that you start studying quite early. And don't leave everything for after all the classes you got. Any questions? Okay, so we have marked your midterms, and hopefully you should get a copy of them sometime today. Right now they're being scanned, so you can get a soft copy of them that you can pick up online. You guys kicked some butt. There was some really good midterms there. So the individual exams, the mean was 75%. The group exam was 93%. And then the overall, after taking both into consideration, the final grade was 78%. So that's where we Okay, you should be able to pick up a soft copy of both your individual exam and your group exam. This was my first experience doing a two-stage exam, so I'm not sure what you guys thought. So if you get your clickers out, and let's see what you guys thought. Yeah, okay.
And then I don't remember who else.
Okay, so other than one person who thought E is the right answer here, most of you found it a good learning experience. I also thought that it was pretty good. It was nice to see everybody collaborate so eagerly. It's hard to usually see that. I'm considering I might do this for the final. I'm not sure yet. One thing that I found out is that I need to have my exams a little harder if I have a group exam to follow it up with, just to get just to get everybody more into the actual second round of discussions as well. I think there was one or two people that they did better individually than the group exam. So for those people, they are going to get basically what they did on their individual exam. Okay, so second midterm's coming up. It's going to be next week. I'm afraid it's a summer course and it's just run, run, run. So midterm 2 is going to be next week today. It's going to cover everything from midterm 1, but I'm going to have emphasis on chapter 5. Okay, so the main emphasis is going to be on you guys being able to write SQL queries. Make sure you study for that one. I'm going to have my normal office hour and also an extra office hour on Friday. That's basically the day before the exam. It was really nice to see a lot of you be active on Piazza just before the first midterm and share your the things that you were studying for. I noticed that a lot of you were going through previous exams and that you found some stuff that you didn't know how to do. So the previous exams, I haven't created any of them, right? And there might be some of those questions that there might have been more emphasis on those in the previous offerings of the course that I haven't put as much emphasis on. So if you do find some questions that you're not sure how to do, or you feel like we haven't done this in class, don't panic. The chances of those coming up in our exam are pretty minimal. Okay, so I won't be asking you questions on stuff that we haven't been covering in our lectures. I've also added exercises for chapter 5 on the exercise page as well. So that's also a good starting point, and some additional exercises as well for you guys to go through that. Any questions? Right, now where were we? So we've been discussing SQL queries. In particular, what we've seen so far is that we have select from where queries. Okay, and this is where we left off. Today we're going to be doing some really nice extended queries, much harder than the ones that we've done so far. So please keep very careful attention on what we're doing, because if you miss the first few queries, then it'd be hard to follow it after that. And at any time, if you're unsure about what we're doing, please just raise your hand and ask, and we can spend more time on those queries. Okay, so let's start with a new running example that we're going to be using today in the lecture as well. So we have students, and those students have name, and they're measuring something. They have a standing. They're either a freshman, they're junior, or senior, and they have an age. We have classes where those classes meet at some time. There's a room for it, and there's a faculty that's teaching that course. We have students. We have enrolled, which means that a student is enrolled in a course, and we have some faculty members that are teaching those courses. Okay, so pretty simple. Now let's start by finding the name of all classes taught by Elizabeth Taylor. Okay, so just to refresh you from what we were before. And just click whenever you're done. Now feel free to discuss with your neighbors as well. Alright, let me put on the starting point is to start with select from where. Think about the tables that you would need to put in the from part. Then think about the conditions that you need to add to your where part. And then think about what attributes it is that you want to return. So then do the select part. That's the name of the family. Class. Oh, where is seating? Oh, so enrolled seating is the same as class name. So professor, you have their ID, and then FD is the name of that faculty.
So the teacher's name is
right? In fact, you have FID and then you have FD. So that's what it is. Right. Okay, guys, so clarification on the schema. So you have a class, that class has a name, And then in role, you're looking at the student ID and the name of the class. So we don't have a different ID for the class. Faculty has FID. Fname is the name of that faculty. And also a class is told by an FID, so that FID and this FID are the same. Yeah?
What is the name of the teacher then?
So the name of the teacher is Fname.
F.
Okay, so as faculties you have an ID and you have a name and you also have a department that you're working for. Let's review these again. So class has a name, and this is what we're using in our enrolled table as well. And in the enrolled table we say this student ID was enrolled in this course. Anyone need more time? Let's look at that first one together. So the first thing I need to figure out is what are the tables that I need. I need the faculty table to get the name of that faculty, and I also need the class table to get that FID of the person who's teaching that class. So these are the two tables that I would need. I also want to make sure that I'm looking only for classes that are taught by Elizabeth Taylor. So one of my conditions would be Fname equals Elizabeth Taylor. My second condition is that I want to make sure that my FID coming from F is similar to the FID that I have in the class. So that means for each class, I'm adding the faculty information on that join. Question?
Really stupid question, but if I switch the clauses, if my Fname equals to Elizabeth Taylor comes to any sense of that is?
The question is, so if I reverse the two conditions that I have, so I have Fname equals Elizabeth Taylor first, and then I have the second one, is the result going to be any different? The result is not going to be any different. Is it going to make a difference for the actual DBMS? Not really, because when it's optimizing, it's going to consider both of them anyway. Any other questions? One thing to note is that I'm using faculty and then I'm using alias F, but when I'm talking about Fname, I haven't added F.Fname. Right? So I have that alias F, but then I'm using Fname without using F.Fname. That's going to be fine because the DBMS currently does not have any conflict in understanding what I'm talking about when I'm talking about Fname. Because there's only one attribute in my database that has Fname. Okay, so when I just refer to Fname, it knows what I'm talking about. However, if I had multiple Fnames in my database, then it would raise an error and would say, wait, which Fname are you talking about? So in that situation, I would need to add that alias F in front of that. Right, and if you want to see what this looks like, apparently Elizabeth Taylor is currently teaching 2 courses. Alright, let's do the second one. Alright, and again click when you're done. Right, does anyone need any more time? Alright, let's give it another minute. Okay, so we're looking for IDs of students who've taken a course named database. So which table do I need? Well, the information that I need is in the enroll table because I have the student ID and I also have the CNAME. Okay, so I'm going to look in enroll and I'm going to look for CNAME being database systems. So that's the course that I'm looking for. The question that remains, both for this question and the previous one, is whether I need this thing there or not. So for this one, I have put it in for now, but can someone tell me whether I would need this thing here or not? I'm trying to return the student IDs of those who have taken a course named Database Systems. Ian?
Yeah.
I will need it because
They could potentially take the course one time.
So Ian suggests that I would need it here because it might be the case that they've taken this course multiple times.
Or two separate students got the same name.
We're looking at their IDs.
Oh, you're looking at their name.
So we're looking at their IDs, so that's not the problem. But the question is, well, can this person be taking this course multiple times?
Then database would not allow the redundancy, right?
Which redundancy?
It will if student ID was the same course, so we have the same tuple twice. Isn't it like database going to...
So the answer currently is that, well, enroll, what's the key for enroll? The key for enroll is student ID and the name of the course. So since the primary key is the combination of student ID and name of the course, my current database doesn't allow a person to take a course twice. Since I can't have that person taking the course twice, then I don't really need this thing here. Everybody has only taken a course once because that's what my database allows. But if I was you and if I had a doubt in my midterm or final, I'll just put it in to be sure. I'm not going to take away marks if you have a distinct that you really didn't need there, as long as I'm expecting distinct values to be returned. So if you think you need to have distinct values, but you're not sure whether what's being returned is distinct or not, it's a safe bet to add that distinct. What about the first query? Does that one need distinct or not? I'm looking for the name of the courses that Elizabeth Taylor has taught before. Okay, so press A if you think this thing is required. Press B if you don't think it's required, and press C if you don't know. There. So you're not sure, I guess. Okay, so how would I know whether distinct is required or not? What do I need to consider if I want to know whether I should be adding distinct or not? I'm going to go back to my schema again. My schema says that for each class, I have name of the class when it meets enrollment and FID. So each class is only taught by one instructor, it's only taught once. I don't have an offering table where at each semester a new person will be teaching the same course. So if I had an offering table, it might mean that Elizabeth Taylor taught the same course multiple times, so I would need to add this thing to make sure that it's only being returned once. However, with my current schema, a class is only taught by one FID, which means that I will not need a distinct here. However, still, if you have doubts, then I would just go in and put that distinct in anyway. Just to clarify, I don't mean to add this thing to all your queries. Right? If you think the result needs to have distinct values, but you're not sure what's being returned as distinct or not, it's a safe bet to add it. If I'm expecting duplicates, then, it would be wrong to add that distinct. And if you run this query, these are the IDs of the people who've taken database systems. Any questions? Yes?
When I look at it, how you set it up, it seems to allow the same professor teaches the same course at different locations, in different rooms.
Interesting. So, the argument is that the same professor might be able to teach the same course in different locations. Would that be true? What's your primary key here? Name of the course. So you can only have one course once in that table. If also, I'm sorry, I'm not sure why the color looks like. If you also had white balance. Is there a negative somewhere? Usually helps. Okay, so if I had room also as part of my primary key, then you were right. Then that would mean that the same course might be taught in different rooms. Currently, that's not true. Good question. Any other questions? Right, let's do this one. So find the departments that have more than one faculty member. And in case you need it, that's the operator for not equal. Okay, this is a little bit more tricky than the previous two. Sure. That's a great question. It's coming up. Right now, that query only considers what we call big data. Okay, so which tables do we need? Faculty. faculty, and anything else? Okay, so a hint is that you can use the same table multiple times. Right? So in my from, I can say faculty F1. That gives me one copy of the faculty table. And then I'll say faculty F2. And I have 2 copies of that table. See whether that might help you in answering this question.
Yeah, under class. The name is underlined because it's the primary key, right? So the name can't be has to be that's
Okay, does anyone have any ideas? Anyone? Ideas? Yes?
We'll have department ID from two separate faculties. F1, let's say F1 and F2. And then the clause would be F1 department ID equals F2 department ID. And F1 FID is not equal to F2 FID.
That's a great answer. So, what I can do is, I can get 2 copies of that faculty table, right? So assume now I have 2 copies. Now I can join these on department IDs. What would that give me if I join them on department ID? Then I would get people that are from the same department in one row. The problem is, I have one Elizabeth Taylor here, I have another one here, and if I join these 2, I'm going to get a tuple where Elizabeth Taylor is in relation with Elizabeth Taylor. However, I only want departments that have more than one faculty member. So what I can do is that I can say, well, let me have two faculties. I have faculty 1 and faculty 2. I'm going to join them on f1.department ID equals f2.department ID. But I want it to be the case that the faculty ID of the first one is different to the faculty ID of the second one. Alright, so let's assume that our faculty table includes these two people. So I have Elizabeth Taylor coming from department ID 11, and I have Jennifer Thomas also coming from department ID 11. When I join these, I'm going to get a tuple with Jennifer Thompson and Elizabeth Taylor. I'm not going to get one tuple for Elizabeth Taylor and Elizabeth Taylor, because although department ID is equal in both of those, I have a second condition which it says the f1.fid needs to be different from f2.fid. Once we know a bit more SQL, there are easier ways to do this. But for now, this is a good way to think about this. It's also a good example to show you why it's nice to have alias, because then I can have multiple copies of the same table. If I was just using faculty, then without an alias, then it was hard to distinguish two different copies of that table. Any questions? So same question, do we need this thing here or not? Do we need distinct? If you just look at this example, when I do this join, I'm going to get Jennifer Thompson from Thomas from this side, Elizabeth Taylor from that side. Next time I'm going to get Elizabeth Taylor from this side, and I'm then going to get Jennifer Thomas from this side. So this is going to give me two department IDs with value 11. I only want the department IDs of those that have more than one faculty. So I will need to have that distinct in just to make sure I get all of those elements. If I have more faculties in each of these departments, then that would mean I will be getting a lot of 11s, right? Let's assume I have 5 different faculty people with department ID 11, then I'm going to get a lot of different combinations there. Okay, so let's run this one as well. So these are the department IDs that have more than one faculty member. If I take away this distinct, currently I have 5 rows. Now I have 36. And you can see 20 being shown there multiple times. Question, if I reran this with taking the distinct out, and I had 5 rows, would that be a proof that I didn't need distinct? No, because it might be the case that in my current instance, it is the case that the distinct doesn't really matter, but in order to answer that, you really need to look at the schema rather than the current instance. Alright, so that's important to understand. Any questions? Because so here you're finding departments that have more than one faculty member. Now find departments that have at least one faculty member.
Otherwise, they wouldn't be on the table.
Hey, so question, how many copies of that faculty table do I need? Do I need one or do I need two? One. How would I do it? Thank you. So although it looks very similar to our previous query, it's rather short. All I need to do is I need to look at that faculty table and I need to return distinct department IDs. Right? I'm storing the department ID for each of my faculty members. So if I go to that table and I distinctly take the department ID of my faculty members, that's going to give me all the departments that have at least one faculty member. Yeah?
Would it return a null if department ID was null?
Yes.
So the question is, would this return a null if one of the department IDs was null? And we're going to cover nulls very soon. We have multiple examples like that. Good question.
So if we don't have any kind of, like, we don't need a where's statement, we don't have to put that.
If you don't need a where statement, you don't need to add it. Right? So one way to start is to start with select from where. And in case you don't need that where, then you can just take it out. Okay, this shows that it's quite tricky to understand whether a query is hard or not. These two seem rather similar. Our one is much more complicated and you would need multiple copies of the same table and need to join it. The other is just to select from a specific table. Now, what if I wanted to find the ID of those students that have taken a course that it had database in it? Right, so this would be string matching. Up to now, what we've seen is how we can find IDs of those who have taken a course database systems, but now we'd like to talk about those people who have taken a course that has database in the name. And SQL allows you to do string matching as part of the where clause. Instead of the operator equal, I can use the operator like. And I can say I want to find CNAMEs like database. And if I add a percentage sign on both sides, that means I want database to be a part of what's being returned in their CNAME. Right? So that percentage stands for 0 or more arbitrary characters on each side of this. If I take away this percentage sign, then I have just database percentage sign. That would mean I'm looking for strings that start with database and then there's some other stuff there. If I use underline, Underline stands for one character. So if I had underline database, that means I can have one character before the database. Alright, so there are many different operators that you can use inside here to make to look for different sort of queries that I'm going to allow you to work on in your projects to get a better feeling about. Any questions? Okay. So when you ask for a query, you're going to get what's returned is a relation or a table. Now the order in which you get those tuples is not guaranteed, unless you specifically ask it to be in a specific order. Again, it's like sets. When you have a set of values, there's no real ordering of those values or items in your set. SQL is the same. If you don't really specify an ordering, there's no guarantee on the order that you get your tuples in your table. However, it might be the case that you would actually need to have things alphabetically ordered. So after you select from where, you can also add order by to ask your table to be ordered by a specific attribute. You can ask for the order to be descending or ascending. The default is ascending. And you can also ask order by multiple attributes. So if I have two attributes instead of one, then first it's going to take the first attribute, and for those who have similar value for that attribute, it's going to look at the second attribute. Any questions? And that would only mean one thing. Click your question. Do this one on your own first, please. Use the addition. Alright, let's finish the first round off in 5, 4, 3, 2, 1.
Let's see, send me.
Alright, discuss it with your neighbors.
Yeah, like I'm guessing the order of the order by.
Right, and click again. 5, 4, 3, 2, 1. Right, so let's look at A. Okay, the value for C for A is 3. And we are ordering by C descending. So would A be on top of 555 or below it? So it would be somewhere here, right? Because we are ordering on C descending, so that cannot be the right answer. What about B? B has the same value for both of the values that we're ordering by. Where would B be? Would it be here, or would it be here? It could be both. Since I'm only ordering on these two, that means I don't really care about the order of all the other attributes. But
Isn't it like database design the way it always inserted under?
some DBMSs do take that into consideration, but it's not guaranteed. Because the optimizer might be moving things around before it gets a final answer. So if there's no, so for situations like this, really there's no way for me to know. What about C? For C, has value C of 6, which is definitely going to be on top of my current. Okay, and if you run that, you can see that tuple 556 is above your 555. Any questions? Okay, just like when we talked in relational algebra, you can also talk about set operators when you're doing SQL. So you can do union, intersect, and except. The big difference and the confusing part is that although SQL is using multi-set or bags, which it usually has duplicates, for set operations, the default is that it's going to automatically eliminate all duplicates. Okay, so for normal queries, the default is that duplicates are returned. If using set operations, then the default is that duplicates will not be automatically in your relation. And if you want it, you need to specifically ask for it. To retain all duplicates, you need to say union all, intersect all, or except all. If you just say union, then what's being returned is that it's going to take away all the duplicates first. It's a little confusing to talk about duplicates when you're talking about unions, right? So let's assume that we have two relations. We have a relation R and we have a relation S. And let's say the same tuple happens 5 times in R and 3 times in S. If you take the union all of these two, it's going to have that tuple in 5 plus 3, it's going to have it in 8 times. If I just say union, it's going to have it once. So union all, it's going to return m plus n, so 5 plus 3 is what's going to be returned. If I ask for intersect all, it's going to look at these two and it's going to return the minimum. So it's going to return 3 if you're doing the intersect all. And by 3 I mean that that tuple is going to be inside that relation 3 times. And if you do minus or except, if you do r minus s, it's going to have it twice. If you do s minus r, it's going to have it 0 times. So it's going to return max of 0 and m minus n. So let's look at IDs of movie stars who've been in movie 1944 or 1974. We already know how to do this one, right? So this one, I can say select star ID, and I'm going to join movie and star in, and I'm going to say I only want star IDs of people who were in a movie in either 1944 or 1974. The other way that I can do this is by using union. So if I have two union compatible tables, again, which means they're going to have the same number of attributes, and the corresponding attributes have data types which are similar to each other, then I can have one table that finds the star IDs of those who were in the movie 1944, and then I'm going to have another table which is going to find the star IDs of those who were in the movie 1974, and I'm going to take the union of the two. Now if you run these two queries, so 8 rows have been returned. These are the star IDs for people that have been in a movie in 1944 or 1974. And now if I run the union, and these are the star IDs, I get 7 rows instead of 8 with these star IDs. Why is that? The two queries, though quite similar, return different results. Can anyone spot why? Very good.
There are duplicate star IDs in the first query.
The first one is returning duplicates. The second one is not returning duplicates, because I'm just using union and not union all. Right? So if we go back to that first one, and order by star ID, you can see that I have one of them appearing twice, which is not being returned when I use the union. Any questions? Okay.
What if we use distinct on the first query?
Then you'll get the same result. If you use distinct on the first one, then the two will be similar. The other question is, if I replace or by and in the first version, would I get the intersection? Yeah, so in the first query that I have, if I say year equals 1944 and year equals 1974, would that be equivalent to the intersection of the two? So if I change that or to and this union to intersection, would I get similar results for the two? I will not. And why is that? Because the first query is saying I want years that are both 1944 and 1974 at the same time. Right? The first query is saying give me tuples where the year is 1944 and the year is 1974. So although tempting, you can't really always take or and replace it with an and to mean intersection. Any questions? As a matter of fact, doing intersection is a little bit more complicated. So if I want to find IDs of stars who've been in a movie in 1944 and 1974, what I'm doing is I'm getting one copy of movie and starring, calling it M1 and S1. I'm getting another copy of movie and starrings, calling it M2 and S2. And then basically what I'm doing is I'm joining M1 and S1 together to find the star IDs of those who were in a movie in 1944. I'm going to use M2 and S2 to get the star IDs of those stars who were in a movie in 1974. Now I'm going to join these two tables to find those who were in both of these tables. Does that make sense? Anyone any questions about that? So I'm trying to mimic doing an intersection without actually using the operator intersection. Right? I'm creating two tables, two copies of movie joined by star, and then I'm taking the join of these two bigger tables in order to find star ID of people who've been in a movie in 1944 and 1974. Okay, so let's run this. Okay, so this star ID is the only person that was in a movie in 1944 and also in a movie in 1974. Let's take away this and let's say star, so you can see what are the two tables that we're talking about. So this M1 S1 joint is giving me people that were in a movie in 1944. And then I also have another table which gives me stars which are coming from 1974. And then this movie ID is the only one, that 1045, that shows up in both of these tables. The easier way to do that would be to use an intersect. Find those people who were in a movie in 1944, find those who were in a movie in 1974, then take the intersection of them. Okay, however, for your exams, I'll be more than happy for you to use any of the operators that we discussed. Okay, so it doesn't really matter if it hasn't been implemented. find SIDs of all students who took operating system design but did not take database systems. Okay, so here I can use the minus operator. First, I can find all of those from the enroll table. So I'm going to go to the enroll table, and I'm going to find those people who have taken operating system. Then I'm going to go to the enroll table, again in a different table, and I'm going to find all those who have taken database systems. Then I'm going to take the SNUMs from the first round, and I'm going to minus that from the SNUMs from what I get in the second table. Any questions? What if I wanted to do something a little bit more complicated? Let's say I wanted to find those. We haven't talked about not doing anything up to now, right? So, what if I wanted to find all those students who did not take operating system design? One way that I can do this is still using the minus operator or the except operator. I can say, well, let's look at all of the people, and then let's look at those that have taken operating system design. And then I'm going to do everybody minus those who have done it in order to get those who haven't done it. That's one way to do it, but there's a more elegant way to do this on SQL as well.